Day 703 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 874, Walking Robot Simulation. The difficulty level is medium, so you already know we're going to keep the solution as simple and easy to understand as well, or as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. A robot of an infinite XY plane starts at point 00 facing north. The robot receives an array of integers commands which represents a sequence of moves that it needs to execute. There are only three possible types of instructions the robots can receive. -2 means turn 90 degrees, -1 means turn right 90 degrees, and if it's 1 or less than or equal to k and k is less than or equal to 9, then we're going to move forward k units 1 unit at a time. Some of the grid squares are obstacles. The ith obstacle is at the grid point obstacles of I, which is point xi, yi. If the robot runs into an obstacle, it will stay in its current position or its current location on the block adjacent to the obstacle and move onto the next command. Return the maximum squared Euclidean distance that the robot reaches at any point in its path. If the distance is 5, return 25. Note, there can be an obstacle at 00. If this happens, the robot will ignore the obstacle until it has moved off the origin. However, it is unable to return to 00 due to the obstacle. North means plus y direction, east means plus x direction, y or negative y means south means negative y direction, and west means negative x direction. Boom, y'all. So now that we understand the question, let's get into the fun part, the actual solution. Now, before we get into the solution, let's just go over what this infinite grid is going to look for. So let's just build it right quick. So we can put that there. Do they have? Okay, hold on. Let me just build this so y'all can see what the heck is going on. Just imagine this is our grid. Say we want to go this way. Let's just do it like this. Then we could back this up like this. Put this here. Put this here. Boom. Let's see. Hold up. Boom. Boom. One needs another one. There we go. Okay, boom. That's now we need one here, and a V here. Boom. So this would be our plus y direction. This would be our plus. Remember, it's a infinite grid, so that's why there's only so far I could build the grid out, because technically it is infinite. So boom, that would be the minus y, and this would be the minus x. Boom. But let's bring this back. Oh, come on. Boom. Okay, so that's our grid right there. So we have our commands. Let's see it. Might be able to, at least the first example. See if we can squeeze 4 of these. I don't think we're going to be able to squeeze 4. Can we squeeze 4? Boom. Okay, so let's see. This is our grid, right? So when we see plus, or excuse me, let's come up here. When we see a -2 or a -1, turn right 90 degrees. So this means turn right 90 degrees, and this 4 and 3 is going to push us in whatever position we're already facing. So let's take a look at example 1 so I can show y'all what's going on. So in example 1, we have our input commands equals an array of integers 4, -1, and 3. Obstacles is blank, so there are no obstacles. The output is 25. The robot starts at 00. So this right here is 00. Boom. It's going to move. So remember, it says up here it faces north. So boom, we start at 00 facing north. So we're already facing north. We come up on a 4. Boom. So it says right here, if k is greater than 1 and less than 9, which 4 is, then we're going to move forward k units 1 unit at a time. So in this case, k is 4, so we're going to move 4 units north. So we're going to 1, 2, 3, 4. So we'd be up here, right after this first command. Then we see this -1 right here, right? Boom. -1 means we're going to turn right 90 degrees. So now we're right here, but now we're facing towards the plus x. So we're facing east. Boom. So now we're here facing east. And then we come right here and we go 3 to the, so we go 1, let's just say 1, 2, 3. So boom. Now we're right here, right? Boom. So we started right here, boom, or we started right here, boom. We moved 4 units north to 0, 4, boom, right here. Then, well, let's just change this with a period because that's where we ended. Boom. Move 4 units north to right here, boom. Then we turn right. Remember, this means turn right, so we turn right, boom. After we turn right, we move 3 units to the east, boom. So we land right here on 3, 4. So let's just say this is 3, 4. The furthest point on the robot ever gets is 3, 4. So after this, once we landed right here, as you can see, there are no more commands, right? All the commands are done. So this right here would be the furthest point we could get, which is at 3, 4, right? Boom. So once we get to 3, 4, then that's when we get the squared Euclidean distance, or we want the maximum squared Euclidean distance. So we take 3 squared times, which gives us 9. 4 squared gives us 16. 9 plus 16 equals 25, so it's 25 units away, and that is how we got our output of 25. Boom, y'all. So let's see, do I have, yeah, that only goes up to 4, that goes to 6. So I'm not going to go through this third example. I suggest y'all go through example 3 on your own, sort of like homework, but I'm going to show you how example 2 works, though, just so we could get another example. And so remember, once again, we're starting right here. First command, so in example 2, our input commands equals an array of integers 4, -1, 4, -2, 4. Obstacles are at 2 and 4. Or obstacles are at 0.24. Boom, the output is 65. So let's go through the explanation. It says the robot starts at 0, 0. So boom, once again, we're starting right here. So we come here. So once again, we're going to move north 4 units. Boom. So we end up here again. Boom. Then after that, we get a -1. We already know from the first example, -1 means we're going to turn right. So now we're right here, but we were facing north. Now we're facing east. Boom. After we turn right, we get another 4. So we're going to move 4 units. Boom, 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 boom. Now we're right here. Boom. More 4 units to the right. Then we get a -2. So -2, ooh, see, -2 means we turn to the left. Boom. So now we're facing north again. Boom. Boom. See, that's what I was worried about. Let me see. Got to add some more points. So, boom. Okay. So now we're right here. We're facing north. Boom. Let me see. So now, okay, now we're right here. We're turning left. Hold on, y'all. Hold on, y'all. We turn right. Hold on. Let me back up, y'all, because how do we get to 1, 4? Okay, we move up 4 units. Boom, we right here. Boom, we turn right. Boom, right here. Then we move east 1 unit and get blocked by, because we have an obstacle right here. Excuse me, y'all. So we have an obstacle at 2, 4. So this right here, for an obstacle, we could just let's put that right there. So we have an obstacle right here. So we only move east 1 unit and we get blocked by the obstacle at 2, 4, which would be right here. Boom. So after we get blocked at this obstacle, then we turn left. Boom. So we turn left. Then we move north 4 units. So we got to go 4 units up. So let's create these 4 units that we got to go up. Boom. So we got 4 units we got to go up. So right now we're here. We turn left, so we're facing north again. Boom. We face north. We got to go 4 units north. So that's 1, 2, 3, 4. Now we will be right here. Let me put the period. Boom, because that's the last position where the period is. Boom. So the final position would be right here at 1, 8. Right? So this is where we're at. This is supposed to represent a 1, 8. Yeah, boom. Or maybe it'd be this. This would be 1, 8, I guess. Or it could be here. It doesn't matter. We're at 1, 8, right? Once we get to 1, 8, the furthest point the robot gets from the origin is 1, 8, right? So this is the furthest point we're going to get. Let me just say this is 1, 8. Boom. So boom, then we do 1 squared, that's going to give us 1. 8 squared is 64. 1 plus 64 gives us 65, and that's how we got our output of 65, y'all. Boom. I hope that makes sense to y'all. I know it was a lot to take in. And once again, like I said, I want y'all to do this third example on your own so you could kind of get a feel for what's going on if you need to. And now that we understand the question, let's get into the fun part, y'all, the actual solution. Solution is not that difficult. Now, first thing we need to do is we're just going to create the direction vectors for movement. So we'll come right here, we'll say let dx equal, open up an array of integers or square brackets 0, comma 1, comma 0, comma -1. Come outside of those square brackets, we're going to say comma, and we're going to say dy equals square bracket 1, comma 0, comma -1, comma 0. Boom. Now we're going to use a set to store obstacle positions for big oval and lookup, and we're going to encode the points x, y into a single integer to avoid using a tuple. So we'll come right here underneath this, and we're going to declare a variable called obstacle set, and we'll set that equal to a set. So set less than integer. We need to put the parentheses right here. Boom. Then we're going to come underneath this, and we're going to say for OBS and obstacles, we're going to open up the brackets, and we're going to shift coordinates by 3000 to avoid negative values and multiply y by a large constant to ensure multiple mapping, or to ensure unique mapping. So we're going to say obstacle set dot insert, open up the parentheses, OBS square bracket 0, come outside of that, plus 3000, plus, open up the parentheses, OBS square bracket 1, come outside of those square brackets, and we're going to say plus 3000. Then we're going to come outside these parentheses, but still inside the other parentheses, and we're going to say times 6001. Boom. Or we could say, we'll say 60,001. Boom. Hold on. Then we're going to come underneath this for loop, so outside of the for loop, and the robot starts at 0, 0 facing north, so we're going to declare a variable called x, set that equal to 0, then we'll say comma y, set that equal to 0, then we'll say comma d and set that equal to 0. Boom. Now we're going to track maximum Euclidean distance squared from origin. So we're going to come underneath this, and we'll declare a variable called max this squared, or max this SQ, we just call it SQ. Boom. And we'll set that equal to 0. Boom. Now we're going to process each command. So we'll say for CMD in commands we'll open up the brackets, and if if CMD equals -1, open up the brackets, and we're going to turn right or clockwise. So we'll say D equals, open up the parentheses, D plus, D plus 1 not divided by, but mod 4. Boom. Then we'll come right here and we'll say else if CMD equals -2, we'll open up the brackets and we're going to turn left or counterclockwise. So we'll say D equals, open up the parentheses, D plus 3, come outside of that and we'll say mod 4. Boom. Then we'll come right here, we'll say else, open up the brackets, and we're going to move forward CMD step. So we'll say 4 underscore in 0 dot dot less than CMD. We'll open up the brackets, and we're going to compute the next position by saying let nx equal x plus dx squared d, come outside of that, comma, ny equals y plus dy squared d. Then we're going to check if the next position is an obstacle. So we'll come underneath that and we'll say if obstacle set dot contains, open up the parentheses, nx plus 30,000, 30,000. We're going to make this 30,000 as well up here. Sorry about that. I said 3, but should be 30. Then we're going to say plus, open up some more parentheses, ny plus 30,000 again. Boom. Then we'll come right here outside and we're going to say times 60,001. Hold on. We get these numbers right. 60,001. Boom. Just like that. And hold on. So that was for our if. Sorry, y'all. And then we come right here and we're going to open up the brackets right here. Boom. Still not done. We're getting there though, y'all. Boom. So we come just right here. And we can stop moving if the obstacle is encountered. So we can just say break. Boom. Then we're going to update the position by coming underneath this. And we are going to say x equals nx. And we're going to say y equals ny. Boom. Then we're going to update the maximum distance squared from the origin by coming underneath that. We're going to say max dist. I don't know why my computer's going so slow. SQ equals max, open up the parentheses, max dist SQ, comma, x times x plus y times y. Boom. Now we just need to return the maximum distance squared reached by coming right here, and we can say return max dist SQ. Boom, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, so where we got an error. Okay, let's remove that period from right there and run it again. See if that did the trick. Okay, let's see. Type annotation missing. Oh my goodness. Where did this M come from? I don't know. Hold on, y'all. Hold on, y'all. What is going on up here? Alright, let's run that. See if that did the trick. Wrong answer, y'all. So you know what that means. If we got the wrong answer, somewhere the math isn't mathing, and I think that's right here. It should be another 0. Boom. So let's check that. Let's check down here. Make sure 30 should be 30,000 everywhere. Let's run it again, see if that did the trick. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 10 milliseconds beats 80% of users. Not bad at all, y'all. So before we go, make sure you get one more look at the song. One more look at the code. This is the top part. This is the middle. And this is the bottom. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.